Alright, welcome to lesson 3. This is our warm-up. We have a couple review problems. You should be looking in your white packet for these ratios and simplifying ratios. Feel free to pause the video anytime to follow along and write things down. Don't worry about trying to do this whole thing in the 10 minutes it'll take, okay? Let's get started. Number 1, 20/30ths, or 20 to 30 and 6 to 9. Are these ratio equivalent or not? Well, we need to simplify our ratios. So let's simplify 20 to 30 first, and I can do that by doing my GCF, my greatest common factor, and dividing by 10 in both my numerator and denominator. This gives me 2 to 3. And then over here, I'm going to reduce my ratio of 6 to 9, and I know my greatest common factor between these is 3, so I also get 2 to 3. So yes, number 1, those ratios are equivalent. Number 2, I have 5 to 15, which if I reduce, my greatest common factor is 5, and I end up with 1/3. 2 to 8, most of us know that this is actually going to be equal to 1/4, and I know that my greatest common factor between them is 2, so if I divide up my numerator and denominator, I end up with 1 to 4. So these are not equivalent ratios. 1/3 and 1/4 are not equal. Okay? Number 3, 100 to 50 and 24 to 12. We could check our ratio values, which we know are, for 100, it's 100 divided by 50, which equals 2. And then for 24 to 12, if I divide them, I end up with 2 as well. So because our ratio values are equal, we know that, yes, these ratios are equivalent. Here are the solutions from the homework. You're welcome to look at these. We will not have a homework check until Monday, so make sure you finish lesson 2, and then we will also have homework for some of lesson 3. Pause the video here so you can check your work. Alright, Mars, lesson 3, ratio word problems. How are ratio concepts applied to solve word problems? So now we know how to find equivalent ratios. We know lots about how we use them, but now we're going to use word problems to solve ratios. Alright, example 1. On Thursday, the middle school cafeteria sold 42 smoothies, 75 mainline lunches, 80 cookies, 51 bags of chips, 100 salad bar lunches, and 26 breakfast bars. What is the ratio of the number of mainline lunches sold to the number of salad bar lunches sold on Thursday? First off, let's look at what the question is. My question is telling me that I'm looking for the ratio of the number of mainline lunches sold to the number of salad bar lunches. Okay? So anything that is not what I underlined, let's just cross it off. So smoothies are gone, cookies are gone, bags of chips are gone, and the breakfast bars are gone. So what do we have left? We've got 75 mainline lunches right here, and 100 salad bar lunches. And we want a ratio of mainline lunches to the number of salad bar lunches. So let's write our ratio. I notice that 75 needs to be my front term, and the multiplicative relationship will be to 100. Now we can reduce our ratio and simplify it by dividing by our greatest common factor of 25, which ends up being 3 to 4 as my final ratio of mainline lunches sold to the number of salad bar lunches sold on Thursday. Students in the Minneapolis Public School District take a field trip every year. Last year they went to the Minnesota Zoo, the Target Stadium, the Bell Museum, Orchestra Hall, the Guthrie Theater, Nickelodeon at the Mall of America, the Minneapolis Public Library, and the Children's Museum. So we have a table down here, right here. And our question is, what is the ratio of the number of 8th grade students who went to Nickelodeon at MOA to the number of 2nd grade students who went to the Guthrie? So let's use our table down here. The number of 8th grade students, which is one thing that we're looking for, that went to Nickelodeon at MAA was 150 down here. The number of 2nd grade students who went to the Guthrie is 120 right here. So we need our ratio of 8th graders to 2nd graders. So 8th graders will be our front term. Our back term will be 2nd graders. And we can reduce this guy by finding our greatest common factor. So go ahead, pause the video, find your greatest common factor, and try to simplify it. So if I list out all my factors, I notice that my greatest common factor is indeed 30. So I'm going to divide out a 30, and my equivalent ratio will end up being 5 to 4. So for every 5 8th graders, there are 4 2nd graders. We will be using this DISC ratio problem checklist a lot as we're going through word problems. So take a look at step 1. We have to discover the problem type. So you can check off as we go. Oops. Check off as we go. There we go. And here you have to read and retell the problem to understand it. So you have to figure out, is this a part-to-part or part-to-whole comparison? Look at the symbols, what you need to find out, and so on. Step 2, identify information in the problem to represent in a diagram or diagrams. So underline things that are important, figure out the values that are important, what do we need to find, etc. Step number 3, you actually solve the problem and do the math. So come up with an estimate, you can plan how to solve it, all sorts of things like that. And lastly, check your solution. Is my answer reasonable? Alright, so down below you can see that I have a little disc down here to help make sure that I'm doing my discovering the problem, identifying information in the problem, solving the problem, and checking the solution. So ratio problem number 1, make sure you're following along. The ratio of the number of girls to the total number of children in Miss Robinson's class is 2 to 5. The number of girls in Robinson's class is 12. How many children are in the class? Okay, so this diagram here will help us, but let's figure out what kind of problem this is. So we were just told that this is a ratio, this 2 to 5 is the number of girls to the total number of children. That total is key. So this is actually a part to whole ratio. Okay? So if we know that 2 to 5 is my part to whole ratio, or 2 is my part and 5 is my whole, I know an equivalent ratio will actually help me out in this case. Okay, so now we're done with step 1. We discover what kind of problem it is. We're identifying the information that is in my diagram. So here's my diagram, and I'm going to fill it in. So my compared value is 2. That's my front term. My base term, my back term is 5. And my ratio value will end up being 0.4. Okay? Now this is where it gets a little tricky. We have to think about how we can use that ratio value. And we'll get to that on Monday and talk a little bit more about that on Monday. But this 2 to 5 ratio, if the number of girls, which is in the numerator here of my fraction ratio, if that's 12 I have to think about how did I get from 2 to 12? Well, I multiplied by 6, and so I have to multiply 6 in the denominator as well. So 5 times 6 is 30. Therefore, I think that my answer is going to be 30 total students. Okay, now final step, we check our solution. So now I need to figure out if there were 12 girls in the class, and I'm looking at my ratio, the number of girls is less than half. So I know that the total class needs to be at least double that 12. So I know that it needs to be greater than 24. That's my estimate. And so 30, that makes sense. And I'm done. On this page, we've got some common ratio phrases. When you see something like this here, we have A to B. That colon there, we just say as 2. Sometimes in word problems, you'll see for every B, there is an A, or for every 2 boys, there are 1 girl, something like that. Or A is to B, we'll have something like n times as much or as many as, so 2 times as much. I have 2 times as much money as Mr. Eisenbrand or something. Sometimes we have A to B, or the nth of, or A per B, so, 3 per 4 units or something. There are lots of different ways that we can think about it. So all these examples down here, we have 4 girls is to 3 boys, 7 pizza orders for every 10 lunch orders, and so on. I want you to come up with your own version using any one of these common ratio phrases. See what you can come up with. All right, ratio problem 2. This is page 17, or it should be page 17. If that's wrong, I'll double check. Last weekend, Will helped his father plant a garden. For every 3 tomato plants, that seems important, they planted 2 basil plants. So I could even draw my little tomatoes. And I could draw a little basil plant. Oop, that was bad. There we go. Got my little basil plant, got my tomatoes. Alright, so let's do our steps. Discover the problem type. Well, let's see. It seems like this is a part-to-part problem. We're not comparing a total of anything. It's one part of a garden to another part of the garden. So my ratio, my compared value is 3 to 2 basil plants. And so now we're trying to figure out our ratio value. That is 1.5 if we divide those. And we end up with planting 6 tomato plants. Let's see. Okay. So we need to have a ratio value of 1.5 with 6 tomato plants, and we don't know how many basil plants there are. Now you could use what we did last time and figure out how to multiply by a common number to figure out what it would be. Or we could find using our ratio value. So let's see, right now we're solving the problem. I personally like seeing that 3 times 2 gives me 6, so 2 times 2 gives me 4. So my answer is 4 basil plants. Final step, check your solution. Let's see, does that make sense? We've got double tomato plants. My estimate about 4. That seems like it makes sense. We're good to move on. We have 2 more practice problems to do. Your job right now is to try them on your own, and I will give you the answer at the end, but I will not explain how to do them. You will have to do that yourself, following your steps down below right here with our disc. That was a terrible circle. I'm going to try that again. There we go. That's better. Okay, so my answer here, I have 2 out of 3. That gives me a ratio value of 0.6 repeating. Turns out my final answer will be 27 total students. Students in Mr. Peters' class. You figure out why this is the correct answer and how we got it. Last problem, practice problem 2. Taylor's soccer team ate at a food court during the state tournament. 5 soccer players ate at McDonald's for every 2 soccer players who ate at Subway. If 6 soccer players ate at Subway, how many soccer players ate at McDonald's? Alright, so this is actually a part to part. We're comparing 2 parts, no holes in here. So I have 5 soccer players for every 2 soccer players at Subway. Here's my McDonald's, here's my Subway. So my ratio value is 2.5. Right? Yeah. Okay. My final answer then will be 15 soccer players ate at McDonald's. And so this is for McDonald's. Your job again is to use DISC to figure out how did we get that answer. And lastly, your assignment is not pages 14 through 16, but instead you'll do the homework listed on the whiteboard in the back. Have a wonderful weekend, and we will see you on Monday. Yay, math!